Hello, this is Mrs. Sigala, and this is the year assignment 4.6, which is due tomorrow, October 22nd. And it's pertaining to acids, which we covered today. Alright, so here I went ahead and included the periodic table of elements along with your polyatomic ions because now your homework has a combination of all these. And so the very first thing that I like to do with my periodic table of elements is immediately as soon as I get it, I want to make sure I include my oxidation numbers. Make sure that you do this as soon as you get a blank periodic table of elements. Okay, it's just going to become second nature to you. So I'm going to go and start off with group 1. I know that my oxidation number for group 1 is going to be +1. Group 2 is +2. I'm going to skip all the way to group 13, and group 13 has an oxidation charge of +3. Group 4 can vary. Okay, it can be plus or minus 4, or it can also be +2. Group 15, however, now it's changing. Now we go back to our negatives, -3, -2, -1, and group 18 will have an oxidation charge of 0. Okay, so I've done that right away. The next thing that helps me stay organized is making sure that I separate my metals from my nonmetals. So I'm going to make my little zigzag line a little bit more obvious to myself. So here it is. I'm going to trace it. Okay, I'm going to trace all my nonmetals. My nonmetals are going to be to the right of the zigzag line. And there's one nonmetal that is the exception to this rule, however, which is hydrogen. So I'm going to go back, and I'm also going to outline hydrogen to make sure I don't forget that hydrogen is a nonmetal. Okay. What I'm going to do next is I'm going to identify those elements that'll give me an ionic compound. Okay, so I don't spend too much time, and I'll explain that once we get started. So I'm going to highlight group 1 and 2, kind of just outline them a little bit. And I'm also going to outline, in this case, these down here. We know some of these are metalloids, but again, in this case, they're to the left of the zigzag line because they're more like a metal than they are like a nonmetal. The metalloids to the right of the zigzag line are a little bit more like nonmetals than they are like metals. And last but not least, right in the center, I have those transition metals. Okay. I'm going to just outline them. I don't want to run it too much. And again, we know that transition metals don't have a specific oxidation charge to them. So that one, those oxidation charges can vary. All right, so next, what I like to do is I like to kind of go through my list, and I like to start off with what's easiest for me to identify. Okay, and so today we covered acids, and we know that all acids will be starting with the hydrogen. That's probably the easiest thing for us to do. So I'm going to identify all my acids because they all start with hydrogen. So you have hydrogen. Here we have another acid. Acid. Don't worry if it's binary or ternary yet. Okay, we have acid. Oops. Acid. And if I forget one, I'll just come back to it towards the end. All right, so I've identified all my acids, okay, because of that hydrogen at the beginning. The next one that's kind of easy for me to identify are my polyatomic ions. And those are pretty easy for me to identify because, again, they're poly, which means many, so they're going to have 3 or more elements in them. Okay, so the first one, oh, see, I forgot an acid over here, so I would have identified it right here. So that's number 9 is also an acid. Sorry about that. And let's see if we have regular polyatomic ions. Yes, we do. So we have 14. It's polyatomic, but we don't know if it's just ionic or if it's transition. We don't know yet, so we're going to wait. I'm going to put a little slash. And then we also have 1, 2, 3, number 18. That one's also polyatomic. Okay. All right, so I've identified all my acids and all my polyatomic ions. Next, I'm going to, I want to identify all of my covalent compounds, okay? And I know that my covalent compounds are composed only of nonmetals. So again, they're going to be to the right of that zigzag line, which I outlined in purple. And so again, you're only looking at these small section, okay, of groups 13 through 18 and hydrogen. So again, number 2, calcium, that's not found within the purple area, so that's not covalent. Neither is Hg. But if you go to Xe and oxygen, Xe is actually over in group 18, right over here, and oxygen, so that one would be covalent. Okay, we go to lithium. No, lithium is in group 1, so no, that's not going to be covalent. We go to phosphorus and oxygen, and yes, that's covalent. Here's phosphorus and here's oxygen, so that's covalent. All right, and then PD, nope, that's not covalent. So I've identified my acids, my covalent compounds, and my polyatomic ions. Next, so I'm basically left with ionic, but I'm not sure if they're transition metals or if it's just regular ionic compounds. So I'm going to look for these, okay, and what a lot of my students do is they really waste a lot of time because they're trying to look at the entire periodic table of elements. What you really should do is you should be looking in groups 1 and 2 and this little area over here first. If your metal isn't found in that area, then most likely it's going to be in the center where your transition metals are. So number 2, we look for Ca. Again, I'm only sticking to these smaller areas. Save a little bit of time, and right away I spot Ca right over here. So that's going to be ionic. Okay. So next, I'm looking for Hg. I look in group 1, there's no Hg. I look in the smaller section to the right-hand side, no Hg, which means that my Hg is going to be in the center, which means it's going to be a transition metal, and sure enough, here it is over in group 12. So that one I'm going to identify as a transition metal. Next, I'm going to go down to number 10, have Li. Right away, I find it in group 1. So that's going to be regular ionic. Okay, then I have my polyatomic ion, but what kind of metal does it include? I look for barium, and right away barium is here in group 2. So that's the regular polyatomic and ionic. Okay. I look for PD. Again, I don't find it in group 1 or in my small section to the right. So I look for PD in my transition metal area, and here it is in group 10. So palladium is actually a transition metal. Next, I look for my aluminum, and aluminum is over in group, right over here, group 13. So that would be a regular ionic polyatomic, okay? All right, so now, after you do this, okay, now you can start naming. And you can start with whatever you prefer, whatever you seems easiest to you, okay? Now, what I like to do is I like to start off with my covalent compounds because those compounds are the only ones that will have a prefix, okay? And so I'm going to start with my covalent compounds, and that way I know that I will not be using prefixes for anything else, okay? So the first one, number 7, again, the rule is you write out the name of the first compound. If there's only one, we do not include mono, but then we look at our subscript for my second element, and there's 3. So my prefix will be tri. And then I'm going to use the root word of oxygen, and I'm going to end it with "ide." So here we have xenon trioxide. Right, my second covalent compound is right down here. I have 2 phosphoruses, so yes, I will be using a prefix. So it's diphosphorus. And a lot of students, what they did is they changed that ending to "ide." In the first part, you don't do that then. You do it only in the second part. You have 5 oxygens, so again, it's going to be the prefix penta. And then the root word of oxygen, which is ox. And then you're going to change the ending to "ide." Alright, so that's it for my covalent compounds. That means I'm done using prefixes, okay? Like di, tri, mono, and so forth. Alright, so next, I like to work with my ionic compounds because those are pretty straightforward, okay? So I'm going to go to my regular ionic compounds, and my first one's number 2. So the rules for ionic compounds, again, is list your metal first. In this case, it's calcium. And then you're going to use the root part of your anion, or your nonmetal. In this case, it's chlor. And you're going to change the ending to "ide." So we have calcium chloride, no prefixes, okay? All right, my second ionic compound is number 10. So again, my metal is lithium. it doesn't matter how many oxygens I have because all I'm going to use is the root part of that, and the ending is going to change to IDE. Okay, and it looks like that's it for regular ionic compounds. Okay, after I use ionic compounds, next I like to work with my polyatomic. Okay, my polyatomic compounds. And so I look for my polyatomic compounds, and we have 14 and 18. I believe that's pretty much about it. So again, I know that it's not a transition metal. That's here, my polyatomic ion. And if I make a mistake, please let me know. And so again, I'm going to name my metal, which is barium. And the name of your polyatomic ion never changes. In this case, N2. I'm going to look for it on my key right here. Here's NO2, and so it's going to be nitrite. Barium, nitrite. And you will be allowed to use the list of polyatomic ions on your list. All right, my next one, we have aluminum as my metal for number 18. So I'm going to write down aluminum. All right, then identify my polyatomic ion, which is PO4. I'm going to look for PO4 on my list, and here it is. Here's PO4, and that one is called phosphate. So the name for this compound is aluminum phosphate. Okay, so next what I like to work on is my acids, okay? Because acids, again, we covered them today, and they're pretty easy. And so I'm going to separate my acids. I'm going to identify those that are binary from ternary, okay, because the rules are different. So I'm going to identify my binary. And binary, again, all that means is that they only have two elements in them. So let's identify those binary ones first. So number 1 is binary. Okay, I'm going to put a little dot next to it. I have number 4 is binary. Number 5 is binary. Number 6 is binary because they only have two elements. Number 8 is binary. Number 9 has 3, so that is not binary. That's ternary. Same thing with 11. And I think that's it for binary. So let's stick to binary acids first. So again, the rule for acids, for binary acids, is you're going to, I'm going to write it down here. So binary acids. You're going to start off with the prefix hydro. Okay. You're going to use the root or stem of your second element. But you're going to end that root or stem with ic. So suffix will be ic. And we're going to add acid at the end. Okay, so there are my rules for binary acids. So again, HCl, I'm going to start with hydro. Okay, my root word would be chlor, CHLOR for chlorine. I'm going to change the ending of that to ic. And my last part is add the word acid. All right, my next one, I have number 4. Again, my prefix hydro. And then I go look at my periodic table. That's a capital I, and that's for iodine. Okay, so that's going to be hydro iod, okay, which is the root or the stem part for iodine. I'm going to change the ending to ic and add the word acid. Hydroidic acid. Okay, number 2 is hydro again. Selenium is my element in this case, so it's going to become selenic, and I'm going to end it with acid. Okay, my next one is H2S. Okay, so again, my prefix is hydro. Oops. Sulfur, so it's going to be sulfic, I believe. Acid. If you put hydrosulfuric, I'm not going to deduct. All right, next one we have And then fluor, F-L-U-O-R. You're going to change that ending to ic, make that C better. And then you're going to end it with acid. Okay, and I believe those are my binary acids. Okay. All right, so I'm going to erase these little notes right here. And then I'm going to continue on to my ternary acids. Okay, and if you remember, in this case for ternary acids, they're going to have 3 elements because they're going to involve polyatomic ions, which are right over here. Okay, again, you're going to be using this list again. Okay, so again, when you get your quiz tomorrow, in addition to writing, oxidation numbers and everything, you can make sure you write down this sentence. As silly as it may be, it's going to be beneficial to you. Okay, so I'm going to use a different color. For ternary acids, okay, you're going to write down I, 8, and icky, white, oops, mouse. Okay, and basically what this is trying to say is that whatever polyatomic ion ends in 8, that ending will be changing to ic. If the polyatomic ion ends with ite, okay, that suffix will be changing to OUS. Okay, and I'm going to keep this